Hello everyone, I am Galaxy Drifter and welcome back to this new video of Trailmakers. As you can see behind me, I have once again the Manta Ray. And why do I have the Manta Ray there? Well, that's because I want to talk about it some more. In my previous video, Jan Niklas left quite a lot of comments. In particular, he wanted to know how did I make it hover so good and how is landing animation is working, if I remember correctly, more or less. And so I want to talk about it a bit more, especially in this field, and going over how I programmed the logic of the spaceship. Now this will be quite difficult to do on this build right here. That's because all the logic is hidden inside and you can see some of it from here, but it's not really the best point of view. So in the past day I did this. I rebuilt it from scratch. I did not just copy and paste it or remove the shell, no. I reprogrammed it from zero to show you how I make my Manta Ray. So let's get right over it. This is the base skeleton of its logic. We can start with this in the middle here. This is basically my flight control, standard flight control that I already showed you in my previous video about planes, which lasted about an hour. So it was quite long, was quite boring, didn't get a lot of views, I understand that. So I'm gonna re-explain it in here. It is basically the simplest thing one can do with gyros. You have 3 gyros, you can use only 2 if you wish. One is for pitch, one is for roll, and the last is for yaw, which is optional, but I like to have it especially on hover builds, as roll alone cannot really handle all the movement. So how do you make it? You take these 3 gyros and you set them on 10 strength. That's all you have to do. Remove the controls and then take an XOR gate, I like to use XORs, and hook them in each respective gyros. As you can see, I painted them, I color coded everything, so everything can be seen easily. And you have to put all your logic gates hooked into your gyros on a 0 point something. I usually go with 0.1 or 0.2. There's really no reason for me to have it any higher. That's because the gyro, if it was directly operated, like if the input didn't go through a logic gate with a 0.2 or 0. Whatever input, the gyros, which is quite strong, and you need it to be strong in order to keep your flight stable, would be way too strong then on the input. It would just flip over your craft immediately, which is not good. So what you do is you hook it up on a logic gate with a 0.1, 2, even 3 if you wish so, input, so the input is way smoother and way more controllable. That's what to do for every plane and every spaceship I make. Next thing that we can see on this flight control over here is the Grammar Galaxy is the gyro stabilizer. I have 2. You only need 2, one for pitch and one for roll. Yaw doesn't need a gyro stabilizer, it wouldn't even work. And they are set on 5 and 7 strength. Usually on YouTube videos I see YouTubers putting them to 10 right away, and I think that's a bad thing to do, because especially on ground vehicles. This is not a ground vehicle, but it can land on the ground. It will just force your build upright. And on many videos of Scrapman and Yuzi, especially where they use land vehicles to battle and these vehicles are a bit unstable, they fix this instability with gyro stabilizer set on 10, and the result is then on hills or climbs the vehicle just is stuck, cannot go up, cannot go down, because it stays perfectly level when the terrain is not, so the wheels don't touch. That's because the gyros is too strong, so you have to use a gyro with a proportional force for the weight of your craft. This is a really light craft, weighing only 400 kilos, just a bit more. The Manta Ray is way heavier, going to 1300 kilos, if I'm not wrong. So it has 10 strength gyros, gyro stabilizers, but for this one there's no need to have 10 strength gyros, so it's 5 and 7. You need to regulate them accordingly, individually, because first of all, the input for roll and pitch are not the same strength, and for second, the weight distribution and thrust rate and everything is different between pitch and roll. So the same value for everything will just not work. With that out of the way, let's get right to the main part of the spaceship. And you can see here, this white part, this is what I call the master switch. The master switch is what controls everything in the spaceship. In this case, I use this for vehicles or crafts that can go in and out of atmosphere and can transition in VTOL. Why do I do this? I do this because I don't like to go on VTOL mode just by pressing a key while I'm in deep space. That will just not work and will just screw up, if I can say that word on YouTube, your flight, will just mess up your flight. So I don't want to accidentally trigger it while I'm in deep space, but it could be nice just to go from deep space to atmosphere, and then the spaceship automatically goes into hover mode, into VTOL. Now, I don't usually use it that way anyway, I just like to fly inside the atmosphere and then activate it if I wanted to, but more usually than not, I like to stay in VTOL and just go high up, and when I'm out of the atmosphere, the spaceship just starts flying on its own, which I find it's really smooth and quite fun. So how does the master switch work? Well, first of all, we have the gravity sensor. The gravity sensor, which I set to 0.1 threshold. That's because I just wanted to pick up the slightest amount of gravity in order to be able to activate the spaceship. Now on the Manta Ray, I think it is a bit higher, like 0.4, but I ended up not liking it and lowering it on my on later builds like this one, because there's a whole room, the whole room planet has a really low gravity, and with a 0.4 input you cannot, 0.4 threshold rather, you cannot go into hover mode inside the whole room, which is quite annoying. So with this lower threshold we can. And the gravity sensor is hooked on an AND gate with just an output of 1. And here we have the XOR gate with a toggle on the number key 1, which is also hooked on the same AND gate on which the gravity sensor goes. And that's basically it. Now it looks like a bit overcomplicated, because if I click on something, everything shows up, which is quite confusing and I don't like it. but that's how things are. Lights up here don't really mean anything, just an indication. This light here glows, turns on when I press number key 1. This light here turns on when the master switch is active. I did it this way, so if you are in deep space, I can showcase it better to you when I'm activating it and nothing's happening, and when instead I'm inside the atmosphere, I'm activating it and it activates subsequently. Here we have a NOR gate. It is here because it's useful to have one, but it's not really necessary for the master switch. These 3 logic gates are all there is to the master switch. The NOR gate basically is just hooked onto the master switch and inverts the input. That's because you want some things to disable themselves when you are in atmosphere, and to add some other things to enable themselves when you are in atmosphere. And so the master switch enables those things, but the NOR gate disables other things, so everything works fine. The master switch is hooked into the gyro stabilizers that I showed you previously, so they only affect the craft when you are in atmosphere and you are in VTOL hovering, and that's how the craft is so stable hovering, other than the speed sensors that I have here. I'll just show you everything at the right time, in due time. So that's it for the master switch. Now let's go to the hover system, which is quite big but doesn't need to be this big. That's because this is basically the only thing that you need to have for hovering, and this is a backup system that I like to have, and not even all of it, just some of it. Is that I implemented 2 different types of hover logic just to show it to you. So let's start with this one. This is a speed sensor set on 0. So the spaceship, as soon as the master switch is active and is in VTOL, as soon as it detects that is lowering itself, it just activates the thrusters. Really that simple. The speed sensor is hooked on an AND logic gate, which is also hooked onto the master switch, as you can see. So master switch and speed sensor set to 0, hooked on into the AND gate, and here we have a NOR gate hooked on with the binded to the control key, hooked into the AND gate as well. How the not NOR gate works, that's also here, is basically it outputs only if there are no inputs, if I'm not remembering wrong, because I used here a lot of logic, but I don't really know how logic works, so I have to double check. Outputs if all inputs are 0. Okay, so basically by default you are not pressing control, so this is a positive input, so the AND gate works perfectly. But as soon as we go to press control, the AND gate does not receive 3 yes inputs, but only 2, and the AND gate needs to have all inputs to be on yes or 1, whatever you say, positive, to work. So we basically disable the hover mechanism, and basically this happens. We are hovering, we are not hovering. Now, it's not really that showcased that well on this build because of this part of the mechanism right here, which I use on the Manta Ray, but I could not have it used at all. I just wanted to implement it because it's nicer, it's cooler to see the engines just spread open in order to let the craft go down. But you don't really need to have it if you have this, basically this base setup over here. This is just for flavor. It can work even without this, without this mechanism over here. Without the left control NOR gate, which is how the Manta Ray works. It doesn't have the left control NOR gate, but it's to me it's better if there is. So now let's go to the second speed sensor, and you might ask why have two, doesn't one works perfectly fine? And the answer is yes, but this is set on a 50 kilometers per hour speed. And why do I did this? That's because I find that 50 kilometers per hour is a really nice speed for every craft in the game not to destroy itself when it crashes onto something. Well, I just got bugged a little bit, but we are still intact. And if you saw it right, once I'm going down and I reach the speed of 50, engines start counteracting the fall. Come on now. So that's why I have a second 50 speed switch, is basically not crash yourself safety pre-built into it. And how does this work? As I told you previously, you don't need all of this part over here. Now let me see what exactly is the only thing that we need, because I don't remember how I set this up. Okay, so basically 1, 2, 3 and 4 we don't really need. All we need is these 3 logic gates, like this, also this. And the setup is basically the same, except we have the speed sensor hooked into the AND gate. Wait, just those two, doesn't need the NOR gate over here. I confused myself. So the speed sensor set on 50 hooked into the AND logic sensor, which is also is hooked the master switch, and it is the AND logic gate with the speed sensor master switch is hooked on all engines. That's the same thing as this one basically, except it's not overrideable. I mean, the NOR gate on left control here is to override the 0 speed sensor, but it's not overrideable, so you don't crash yourself on the ground when you come in a little bit too hot. And now here, the mechanism that regulates the rotating servos for the engines. First, I need to talk about how I made the rotating servos. So let me just select them. And here it is basically. No inputs on the servos, angle 180. I didn't do it like this on the Manta Ray. I set the front ones to 90 and the back ones to 180, if I'm not wrong. And it causes me, it just was a bit too complicated, because you have to factor in different output scales, input scales for every logic that you have, and just a mess. In this case I just put everything on 180, and it works basically the same without any problems, and just simpler to remember your values. So there it is. Now, a thing you have to remember is that one side has to be on minus speed, and the other one should be on positive speed. That's because how things work. If you mirror it, it will just flip, basically rotate in the opposite direction, so you have to reverse the speed in order for each side to be perfectly symmetrical once you go to fly. So that's it for the, not really for the rotating servos. Now let's take a look at the rest of the descent mechanism. So we have the speed sensor hooked onto an NOR gate, which is hooked into an AND gate. So the NOR gate is here, so the speed sensor, the NOR gate is here, so the speed sensor can override the animation for the rotating servos to open, so they just close back on and give some more thrust, so you don't crash yourself. Yeah, okay, I was a bit confused about what I did, but I got my bearings. So we have the AND gate over here. Onto the AND gate we have a NOR logic gate, which is hooked into the 50 speed sensor, or rather the inverse. The 50 speed sensor is hooked into the NOR gate, and the NOR gate is hooked into the AND gate. Also we have a left control XOR gate hooked into it, and the master switch hooked into the AND gate. And then the AND gate goes into two XOR gates, one for the front engines and one for the back engines. The front engines are set to -30 and the back engines are set to 30. That's because they move in opposite directions. And that's basically it. So once you are in hover mode and you want to descend, they open up. Pretty simple. Next thing we could talk is basically the engine inputs, which are really simple. Every engine is hooked onto space as default, nothing strange over there, but they are also hooked onto a Alt key on toggle and to a left shift on press. That's so we can have a sort of a gear system with a low gear, medium gear and high gear, so we can better regulate our thrust in different scenarios with a higher or lower gravity, which might require a little bit of finer thrust control. This is the simplest thing to do. You just leave your every engine on space as default, and you take two XOR gates, which don't need to be hooked on anything basically, and just the first one you put Alt with toggle. I like to have Alt just because it's right next to the spacebar, and hook it in every engine you have. Same thing for the left switch, for the left shift switch, but you just don't put it on toggle, and that's it. Easiest thing done. Now let's go to the brake. We did acceleration, now we do brake. And the brake is basically just these two logic gates over here. First thing we have is an XOR gate hooked on left control. And then we have an AND gate hooked into the NOR gate of the master switch. So basically what this does is, if this master switch is disabled, the air brake can be activated, but if the master switch is enabled, the air brake does not deploy. As we can see, the master switch is deactivated, so we are in flight mode, and I press Ctrl. The air brake opens, and now if we are in space or just flying, we decelerate. If I activate the master switch, as you can see now we are in hover mode, the air brake no longer opens, it stays closed. Instead, the engines are allowed to descend. And that's basically it. You just need two steering hinges to spread apart the quantum rudders, and that's it. I like to set my steering hinges on a 60-degree angle, and that's all there is. This is the simplest part. It was more complicated to showcase to you the descent mechanism and the hover mechanism than it was for the acceleration and deceleration mechanism. And now we have the most complicated part, which is the thrust vectoring and the rotating servo controls. Now it's not really that complicated, it's just a bit confusing to see. Oh, and I forgot, before we talk about it, the wings, as you know, on my Manta Ray, the wings fold open and close based on if we are in atmosphere or out of atmosphere. This is basically the same, but it's really not that difficult. You just take your master switch, hook to rotating servo, also in this case hinges for the Manta Ray's rotating servos, and that's it. It is done. I just forgot to cover it before. So that's it. So now let's go to the thrust vectoring. Let's start with these two. What are those? This is basically the rotation for the engines when we are in atmosphere. It's just an XOR gate. We have two of them, one for the front engines and one for the back engines, that are hooked with that receives input from the master switch, and that's basically it. On the Manta Ray, the engines are perfectly vertical in respect to the ground, so 90 degrees straight, and that's because initially it had a slight opening of the engines, but found out that the Manta Ray is really heavy and needs as much power straight below it as possible in order to lift itself up, otherwise it would just fly. For this lighter contraption, that's really no problem, so I can have a bit more aesthetically pleasing, slightly open engines, so to show you everything. So that's it. And that's basically it for the transition from flight to hover. Simple, easy. Oh wait, I almost forgot an important thing of this build before closing the video. I just finished the recording and I had to open it back up, so I might have to do a bit cut and splice over here and there. I was forgetting about a really important thing about how it hovers. Now if we go to tools, we can see the forces, which has you cannot see really much, but what we are interested in is the center of mass. On this case, the center of mass is pretty centered, so that's not really a problem, but on the Manta Ray is really off center. But what it causes to have a center of mass of balance is for the spaceship to pull when hovering, so it just drifts slowly into a certain direction. And how we can simulate this is just by, over here, adding a bunch of weight in the front or the back or whatever you want. So now let's double check. Yeah, our center of balance is a bit forward, and what it does is, if you go to hover, this, our spaceship, our craft, just goes forward by itself because of the excessive weight in that direction. And how do we fix this? That's where this comes into play. If you remember, this is the logic, the SO gates, that determines how wide open or closed are the engines while in a hover mode. And so if we take the forward engines, we can better regulate how open they are when they are hovering. So I don't remember exactly if I should add or subtract now, but if we try, let's try adding. If we add a bit more opening, like this. Was it like this? No, it was the opposite direction. So if we close it a bit, let's say, let's go for 50. If we close it a bit, now they are not symmetrical anymore. The front ones are pointing straight down, and this will not really. Let's do something like this. I think I should remove over here. Let's go 20. Okay, yeah. And now as you can see, we are a bit way more straight than we were previously. We just crash. Right, fantastic. But this doesn't really work as it is now because we are too oops, we are glitching. We are too off balance, too much weight in the front, so I just move it in a bit, and we are being propelled forward by default. So let's try again without that much weight in front. Okay, we are at a point, so I managed to understand what the hell I did wrong, and basically with some try and error, that's what I did as well for the Manta Ray. I figured out what was going on, and thing is I was basically making everything wrong. So we are nose heavy now, so what we should do is open some more the front engine to counteract the forward momentum that we have. So by opening the front engines, we are pushing back a little bit more. And by pushing back this time, we are also pushing back a lot. As you can see, we are nose heavy, but we are going back. And why is that? So first thing, as I told you, you have to up your gyro. And second thing is to regulate the trim for your engine. So now we are going back because the front engine, we are still front heavy, but the front engine is too wide open compared to the back engine. So what we can do is either open back up the back engine or close back in the front engine. And I'd say let's open a bit the back engine, like 48. And let's see if we are doing better now. No. 46. Okay, we are still going back, but slower this time. Come on. Now we are going forward once again. That's because we open it too much and the weight in the front is pulling it once again. So 46 was too little, 44 is too much. Let's try 45. Just a second. Okay, we are standing still. Let's try again. Let's counteract it a bit. Okay, we are drifting forward still, just a tiny bit. So let's try open it a bit more, the front engine. Well, it does appear that I'm not able to fix this, but this is actually quite an extreme off balance of weight, just done for test purposes, just to show you how you should go about it. in order to find how much you should tweak it or not. Well, okay, more or less I think I managed to stable it out as much as I could. So after all this, we are at 62 forward, 40 back, and 7 strength for the gyro stabilizer. Unfortunately, this is the most annoying part of setting everything. The best thing you could do since the beginning, when you first start building, is always always make sure that the center mass is actually in the center as much as possible. That's the best thing one can do, and then you really have to put in the time for trial and error with the engine trims. Oh well, let's close this here and let's get right to the main part of the video. Let me see how I did it, because I already forgot. Okay, I remember now. First thing, as you can see, these are on red and these are on blue. That's because I switched the colors around. So let me fix that. Okay. Okay, now let's give it a save. Okay, I switched the colors around unintentionally. So these are blue and red because the gyros are blue and red. Blue for pitch and red for roll. And that's basically the same. Blue logic gates go for pitch and red logic gates go for roll. And this is for the thrust vectoring. As you can see, the engines move around, so I can better steer. Well, it's not really for better steering, it's just aesthetically pleasing, so I wanted to put it in. It just looks cool. And how this works is we need to have a set for each keybind. So a set of 3 logic gates for the S key, another one for the W key, another one for the D key, and another one for the A key. It's not really required for yaw, because, well, with this setup you cannot really do thrust vectoring for yaw. So that's it. How does this work? First of all, we need an XOR gate for our input. In this case, the first one is S rather than X, S. And we have also W, D, and A. It's basically everything the same, just a copy paste of the same logic disposition. The S key is then input hooked into 2 AND gates, and these 2 AND gates receive an input from the NOR master switch logic gate. That's because the thrust vectoring only works if we are in hover mode. And so you take your AND gates and hook them up, one to the front engines and the other one to the back engines. And I gave them just this slight inputs, 0.05 and minus 0.05. You need to have 2 different, one with the positive and the other one negative, because the engines just have to rotate in opposite directions, otherwise they would turn in the same direction and it wouldn't work. I guess you could maybe invert the direction of the rotating servos to begin with, but I find myself to be easier for myself to understand how I'm making my things this way, so I just keep it this way for you as well. And that's it. We do this once and then we do it other 3 times, and it's basically the same. Nothing different. Only thing that changes is that from pitch to roll. Instead of giving it front engines and back engines, you just give it left engines and right engines. That's the only difference there is. If you're a bit confused about why I rotated the logic gate this way, how arrows pointing some way and other ways, it's just for myself, so I remember which logic gates does what and to which side of the craft it is referring. And that's it. The only thing that's left is the landing gear and this thingy over here. Now this thingy over here is the trim controls. Now if you're not familiar with planes, sometimes they need to have a little bit of a trim on the wings. What is that? Basically, if a plane, especially in Trailmakers, if it's not able to fly straight with its wing on a neutral position, it might be that it naturally pitches up or usually naturally pitches down. So what you do is set just the slightest inclination of the wing from its start position, so it just slightly corrects the plane on its flight trajectory to have it a little bit straighter. This is the exact same thing, and the setup is basically the same of that, except instead of being XOR gate they are AND gates, and they are hooked into a gravity sensor. Why is that? That's because I found out that you need different trims settings for different gravity situations. So this is set for below 0.10, so this is for interstellar flight, for space flight, but the Manta Ray has actually 3 of these, one for deep space, one for half gravity and one for full gravity. That's because the Manta Ray is a really heavy craft and it struggles a lot to fly in atmosphere actually. So I needed to give it a little bit more trim. For this one there's only one, but it can be freely regulated based on your needs. So the AND gates are hooked on the 0.1 trigger below logic gravity sensor for when we are in deep space, and the NOR master switch logic gate, so it only activates when we are in flight mode. That's the setup for every trim control you need to make. The exact same thing, doesn't change a thing, you just copy paste it for as many as you need for every gravity situation that you need. Maybe you could do one for deep space, a second one for half gravity, one for full gravity, and then another one for 1.5 and another one for 2 gravity. You don't need more than 5 in my opinion. The Manta Ray has 3 just because it cannot fly on 1.5 or 2 gravity, it just crashes, it's too heavy for its own good. So that's it. The AND gates are then hooked into back and front engines, the exact same principle over here. And you just give it as much output as you need. Now this craft is really light and flies pretty straight, so it didn't need that much, but for showcase purposes I just put it a bit, so does this work? I know, well, this is for deep space, so let's go here. No, whoop, this one. Okay, as you can see, if we are in 0 gravity, they automatically auto adjust to make it fly a bit straighter. That's it. And if you need to change your gravity settings, that's the word I was looking for, you just go here, change your gravity settings, then go here, no, here. And that's basically it. Why is it not activity now? Did I do something wrong? Or maybe I need to lower it a bit, like this. Yeah, it was a bit too high on the threshold. Okay, and that's basically it. And you can adjust this independently based on how much the engine style golf is more of a front heavy, back heavy, or whatever you have. This is really light, so it doesn't need that much. That's everything it needs. And which this just leaves us with the landing gear, which is really simple. Just 3 logic gates, 2 pistons and 2 hinges. Now this is different from how I set it up for the Manta Ray. This actually works a bit better. Well, first thing I want to tell you is that I don't really like landing gear. I just did this because it was cool to see, nice to see, a really nice touch, but nothing more. In general, I don't like landing gears because they add drag, they make your build heavier, slower, and you don't really need it. But for this case, I made an exception. How this works is you have a distance sensor, 2 distance sensors actually, both set on 10 distance. That's just what I thought was a good height in order to auto deploy it. One is on an invert trigger -1 output scale, and this is for basically the pistons and the steering hinges on the top, so they close when it does not detect the ground. And this is for the feet, just to deploy instead when the ground is detected. And that's basically it. Now, the first distance sensor is hooked directly into the landing gear. The second one is only hooked into the feet, and we have and it is also hooked into an XOR logic gate in order for the hinges to close the landing gear, or instead to open the landing gear when the ground is detected. Now that's how I set up the various parts. I found out that pistons are a bit glitchy if they touch other blocks, so a 90-degree angle on the steering hinge on top was a bit too much, but an 88, 89 maybe angle is a bit better, just because it does not look that off. It just looks like it's a 90-degree turn when it's not, and it's basically a good compromise between having it fully closed and just not to glitch out too much. That's the piston settings. This is the same for every pistons. Start position 1, auto reset. The setting for the bottom steering hinge is just 30°, and the light is just for an aesthetic touch. And that is all, I would say. That is basically it. There's nothing more to say about how I made it. If you want to know something more about it, you can leave it a comment in my comment section. Ask your questions. I'll try to answer them as best as I can. I hope that I was able to explain everything without leaving you any doubt about it. It's been nice having you here, so thank you all for watching. I've been Galaxy Drifter, and we will see each other in the next episode. Goodbye.